Hello, everybody, and welcome. Grab a seat, grab a beer, grab a seat. My name's Michelle Kasperzak. I'm a curator here at V2 Institute for the Unstable Media. And I want to warmly welcome you tonight to Blowup, New Materials, New Methods. So tonight we're going to be looking at the role of new materials and how this relates to our conceptions of innovation, creativity, and imagination. Wondering what the impossible dream for new materials are today, and who or what will dream them. This topic grew out of a 2-year research project we've been doing here at V2 about innovation in extreme scenarios. We've been looking at this kind of wonderful buzzword of innovation and thinking, how and when does it actually happen? Is it the same thing as creativity? Is everyone creative? We tend to look at the art sector as being a very highly fertile and creative field, but of course scientists are also creative, etc. And we could kind of expand this to a much wider field. So this is looking at the potential for new materials and the potential for the new methods that they might inspire became a key part of the findings that we uncovered in this research. I don't want to connect too many dots for you because tonight's program is really diverse. And not only is it diverse in terms of the people who are presenting, but it's also diverse in the sense of the different types of presentations that we have. We're going to start off with a very special presentation from the Pykrete Dome team. I'm going to tell you just a little bit about what that is. It's the world's largest ice dome, and Pykrete is a very special material which inspired us actually in the very early days of doing this innovation in extreme scenarios research.
My name is Rob Luijmen, and together with Jongert, I graduated last year on the Pykrete Dome project, which I will tell you now a little bit more about. First of all, we go back to the Second World War with Geoffrey Pyke, the inventor of Pykrete, as we can say. He wanted to build a large aircraft carrier out of Pykrete that never pulled off, but still the material is very strong, which is actually a fiber reinforced ice, which can be compared to reinforced concrete. So you can do many more things with it than not just regular ice. We combined this technique of Pykrete with a different technique, which comes from a Japanese researcher, Tsutsumu Kokowa. And he uses an inflatable mold where you spray your material on and it freezes over, so you get a large shell structure. We use the Pykrete on the lower circle where the forces are the highest. And on the upper part of the dome we use regular ice, so you keep the translucent appearance of this ice and the strength of the Pykrete in the parts where you need them the most. As you can see here, this is the dome nearly to the finish, to the end, with some help of the fire department. And after removing the membrane, deflating the membrane, removing it from the dome, you get the result. As you can see, you see the top of the dome still translucent from the ice, and the side of the dome a strong Pykrete appearance.
Were there any points that you felt uncertain actually entering into the dome for the first time?
Yeah, actually there was. But we tested the dome before entering. We deflated the membrane, and with a crane we put 2,000 kilos of sandbags on top of the dome, and we measured the displacement, which was next to nothing. And compared to the test model we made, it was actually really good. So we were confident enough to enter. Yeah, because at first the community of the village wanted to organize a real event, and they want to play a band in there and for about 200 people. And we said, no, we don't want that because we don't know what happens if there are 200 people at once inside. Does it heat up too fast? We only allow groups of 20 people at once, and so we had like guards, which we ourselves were. But
Yeah, hi Hi everyone, I'm Boukje Cnossen, and I'm here with Maria Verstappen and Aaron Driessens because I've recently written an essay which came about in the context of a project for Dutch art critics. It's called the Vuurlinie. I wrote about Driessens and Verstappen's work, and it was published in Dutch last week in the Gids, which is a literary magazine here in the Netherlands. So the leading question of this interview will be actually, what can computers teach us when it comes to imagination? And in the essay I wrote, I took as a starting point this idea that, you know, robots are increasingly taking over human labor and are sort of becoming smarter and smarter, and that we might have to fear them. So without wanting to answer whether that's true or not, I was thinking about flipping the question around and thinking, instead of, you know, how robots are becoming more and more like human beings, how can we become a bit more like robots? And particularly when it comes to imagining things. And then when I say imagining, I mean that literally, so in the sense of producing images. And that brought me to the work of Driessens and Verstappen, and particularly the work which we see here, solid spaces, because this is a very good example of how machines can imagine things.
The work is called Solid Spaces, and the project until now is containing 3 different sculptures that came out of what actually this robotic camera has recorded. And the recording of this type of camera is a type of recording that is done with a laser sensor, which is normally used on building sites. It is a laser that can actually measure distance by light, by a laser beam. So we were thinking about making a site-specific work, but then make a fully automatized system that could create kind of site-specific sculptures. What you see here on the pedestal is made with the point cloud that you see on the screen here. Within the point cloud, you can see now how the space looks from the perspective from the machine. So the machine is standing at one position in the space and takes samples totally around it. What's happening, of course, is that the space that you would perceive from that particular point in space is become massive. So it's like a reversion, actually, of the space.
And hence the name Solid Spaces.
That's why it's called Solid Spaces, yes. We were also thinking about limiting it to exhibition spaces, because I think it could make a nice collection over time of spaces that are exhibition spaces. And a church nowadays can be used as an exhibition space, or an old factory building, or here it might have been a shopping space, or even some houses are transformed in exhibition space. So as you take exhibition spaces as your kind of reference, then it could be any type of architecture that could deliver interesting kind of sculpture forms.
Not a cube and not a sphere.
Not a cube and not a sphere?
That would be very boring. It would look
the white cube,
same.
yeah, would be very boring.
It
But
would
there
look
is
the
no
same
white
from
cubes.
Any viewpoint.
Right, so there have to be
There have to
obstacles.
Discontinuities in space. There has to be overlap for it to look different.
Great. Well, thank you very much. Everyone join me in thanking them for the wonderful interview.
Yeah, so I'm Jan Jongert, running a studio with around 13 people at the moment in Rotterdam. We were before known as 2012 architects because we had a 15-year deadline of our first studio, but actually in 2012 we decided to change our name towards the main strategy that we had developed in the first 15 years, which was called Superuse. We're looking at our cities as entities that where flows are going in and out. So these can be flows of money, energy, food, etc. And this is what we often make, it's called a metabolist analysis of, in this case, 3 neighborhoods next to Heerlen, where we show the distance and volume coming before they are consumed, and then when they're consumed, where they are transported afterwards. And often we see that the biggest flows come from far away, and when they're used once, they are transported again far away. That's the outer circle. Our office is looking at our environment and looking if we can actually, the existence of those flows in our environment, we can optimally use them and give them more value on the site where we find them without having to import new ones. Yeah, for my research group, we published a book showing a lot of showcases that actually already have worked from this content. One of the nice ones, for instance, Ellen Wexler, an artist that designed a bathroom that is where the space is defined by the amount of water that you need on a certain spot. And that's really where our interest is. How can actually this flow start to define the space that we're living, and how is it going to transform the designs in our environment? First, let's say 10 to 12 years, we've mainly been looking at material flows in our city, yeah, looking even at the symbols of our new green energy, so to say. We found that actually the materials that they're made of are not that green. So, for instance, these windmill blades, they come off each 10 to 15 years. There's like 200, 250 yearly that in the Netherlands alone are being wasted. A playground we built for the city of Rotterdam in the north part, the Wikado it's called, where we actually included existing parts of the old playground and connected them with the windmill wings. We just cut them 2 or 3 times, drilled a couple of holes to be able to actually go into it. Because these elements are so big that, yeah, especially for kids, you can actually enter them and play hide and seek. Biggest project so far, we realized we had a lot of ambitions with windmill wing here. I must admit that were not met. Using it for natural ventilation, water storage and so on, but it became a signpost of a recycling center in Maastricht. But there we included window frames from demolished buildings and cut-offs from steel industry as a cladding. And then very close by, just this other, across the wall here, Worm. This building was actually their new venue a couple of years ago, and they asked us to redesign it together with Van Lieshout. We made a harvest map for them, again, showing what kind of materials would be available. This is also for us to discuss with them what will we actually use in it. And then really like things we find in the space, in the building itself, I mean, that makes the biggest impact in reuse from the environmental point of view, were these, this shelving or archiving system that was really on the spot, and we just cut it and turn it into seating that can actually be moved still on the existing rail that was in place. Airplanes, we can order now stretches of 3 meters of airplanes from Zealand that are demolished there and use them, but for Worm we just used the inside lining to create a sound, a good acoustical interior.
And now, for our final presentation this evening, we have something pretty special. I'm not going to blow too much of the surprises, but I just want to say that this is a very special reenactment of a lecture that took place 55 years ago. And this lecture was conducted by a man named C.P. Snow, and it was called The Two Cultures. It was part of a series of lectures, the Reed Lectures, and this particular one is often quoted when we discuss what we now speak of today as the gulf between art and science. And this is something, of course, that 55 years has passed, and we're still, of course, dealing with this kind of these gaps between this perceived gap and an actual gap between art and science.
I believe the intellectual life is increasingly being split into 2 polar groups. When I say the intellectual life, I mean to include also a large part of our practical life. Well, because I should be the last person to suggest that 2 at the deepest level can be distinguished. I shall come back to the practical life a little later. Two polar groups. At one pole, we have the literary intellectuals, who incidentally, while no one was looking, took to referring to themselves as intellectuals as though there were no others. Literary intellectuals at one pole, at the other, scientists. And as the most representative, the physical scientists. Between the two, a gulf of mutual incomprehension, sometimes, particularly among the young, hostility and dislike, but most of all, lack of understanding. They have a curious, distorted image of each other. Their attitudes are so different that even on the level of emotion, they can't find much common ground. Non-scientists tend to think of scientists as brash and boastful. The non-scientists have a rooted impression that the scientists are shallowly optimistic, unaware of man's condition. On the other hand, the scientists believe that the literary intellectuals are totally lacking in foresight, peculiarly unconcerned with their brother men, in a deep sense anti-intellectual, anxious to restrict both art and thought to the existential moment. It is bizarre how little of 20th century science has been assimilated into 20th century art. Now and then, one used to find poets conscientiously using scientific expressions and getting them wrong. There was a time when refraction kept cropping up in verse with a mystifying fashion, and when polarized light was used as though writers were under the illusion that it was a specially admirable kind of light. Of course, that isn't the way that science could be of any use to art. It has got to be assimilated along with and as part and parcel of the whole of our mental experience and used as naturally as the rest. One is our fanatical belief in educational specialization. The other is our tendency to let our social forms crystallize. This tendency appears to get stronger, not weaker, the more we iron out economic inequalities. And this is especially true in education. It means that once anything like a cultural divide gets established, all the social forces operate to make it not less rigid, but more so. In fact, the separation between the scientists and the non-scientists is much less bridgeable among the young than it was even 30 years ago. 30 years ago, the two cultures had long ceased to speak to each other, but at least they managed a kind of frozen smile across the gulf. It is not only that the young scientists now feel that they are part of a culture on the rise while the other is in retreat. It is also, to be brutal, that the young scientists know that even with an indifferent degree, they'll get a comfortable job, while their contemporaries and counterparts in literature or history will be lucky to earn 60% as much. Education isn't the total solution to this problem, but without education, we can't even begin to cope. All the arrows point the same way. Closing the gap between our two cultures is a necessity in the most abstract intellectual sense as well as in the most practical. When these two senses have grown apart, then no society is going to be able to think with wisdom. For the sake of the intellectual life, for the sake of Western society living precariously rich among the poor, for the sake of the poor who needn't be poor if there is any intelligence in the world, it is obligatory to look at our education with fresh eyes. Isn't it time we began? The danger is that we've been brought up to think as though we had all the time in the world. In fact, we have very little time. So little that I dare not guess at it. Thank you.
Thank you very much. Given all of the viewpoints that we've gone through this evening, I think there is considerable digestion that needs to take place. So I'd like to thank all of the speakers again tonight with a big round of applause. Please join me.